So in the last class, I think so we have completed till momentum, right?
Yes, sir.
ठीक है, चलो, let's start with the next portion, that is the, so Irshad hasn't joined yet. Just a second. Sure. Okay, everyone. So in the last class, we've started, well, like we have completed the third, basically till the momentum part. Right now, we are going to start with the second law of motion. Right. So let's understand and revise the second law of motion. Is there anyone who is having doubt in this, in till momentum till now?
No, sir.
Sara, Tejas, Astitva,
No, sir. I
Farhan, and
don't
Safia.
have.
Okay.
No,
No,
sir.
sir.
Farhan.
No, sir.
Sir, I didn't understand the main definition of momentum.
So basically, the main definition of momentum is the product of mass and velocity. That is the main definition of momentum, sir. The product of the mass and velocity. I've written the main definition in the first statement itself. Look at the statement that momentum of body is defined as the product of mass and velocity. That is the main definition. Clear?
Yes, sir.
Chalo,
Yes,
that's
sir.
it. Okay. Now let's understand the second law of motion. What does it say basically? So now, okay, so the thing is that the second law of motion is basically just the extended part of the momentum, right? So it means that let me basically dictate the statement. So one more thing before everyone, I just wanted to ask that did you get the notes that I have shared to all of you? PDF of the note,
Sir, which note?
motion and force chapter, the same notebook note PDF.
No, sir.
Okay, ठीक है.
No, sir.
Just a moment. Okay, everyone. So you will get the notes. I've shared them again. So they are basically sending it to you right now. Okay. So this is the same. Okay. So this is the, I've basically made a PDF of this. Okay. So you'll get the notes. All the things are there. That is we have done in the class. Okay. So you can use them as the quick revision notes along with your notes as well. Okay. So so let's understand the rate of change of momentum of a body is directly proportional to the applied force, and okay, and this force will basically takes place in the direction, basically this motion will takes place in the direction of force. Clear? So force is directly proportional to the change in momentum. It means that suppose the body was moving with some initial velocity u, after applying force on that body for a certain amount of time t, the velocity will change, everyone. Yes or no? If I'm applying some force on a body, will it change or not? The
Yes,
velocity
sir.
of that body will change. Okay. So that body will change its velocity. And as you know this thing, that velocity is changing. It means that there is some certain external force applied on it or not. Yes or no, everyone? Clear?
Yes, sir.
Okay. So that's why force is directly proportional to the rate of change in momentum. Basically, rate, whenever the word comes rate, it means that that property is divided by time. Change of momentum divided by time. That means rate of change of momentum. Am I clear to all of you? Please do let me know.
Yes, sir.
Yes, sir.
Okay. That's great. That's great. Okay. So as you can see, actually one more thing. So this is the thing that you have to write before deriving the equation, because the teacher should know from where you have taken the v and u and t. What is the meaning of the actual meaning of this? Because I've seen this thing that some of the students have not written it yet, like just derived the equation directly. So that is not the case. You have to explain these things as well. Am I clear to all of you? So you
Yes,
have
sir.
to tell to the teacher, you have to explain that how did you get this like initial velocity, final velocity, how did you get initial momentum, final momentum. So this is the statement that you have to show to the teacher for the explanation. Am I clear to all of you?
Yes,
Yes,
sir.
sir.
Okay. So I'm not basically dictating it. So it's basically explaining that what is U and what is MU, that what is T. So is this state like basically this para is clear to all of you or not? Please do let me know
Yes,
everyone.
sir.
Yes, sir.
Safiya, Farhan, Sarah, Stetvan,
Yes,
Tejas.
sir.
Yes, sir.
Chalo,
Yes, sir.
chalo. So force is directly proportional to the change in momentum. So change in momentum is final momentum minus initial momentum. Whenever we have to find the change, it means that we are subtracting the final minus the initial. Am I right or not?
Sir.
Yeah, divided
Yes,
by
sir.
time. So basically what I've done is that in the next step, M is common and V minus U is this and divided by T is left. Basically M is common right here. So I've taken M as common so that I can basically simplify it a little bit, right? So what I have seen is that MV minus U by T, it is nothing but the change in velocity, rate of change of velocity. Am I right? Final minus
Yes,
initial
sir.
by time. The rate of change of velocity is nothing but the acceleration. It means that whenever the force is exerted, unbalanced force, one more thing, everyone, not balanced force, only unbalanced force will produce the motion and acceleration. So this force is basically unbalanced force. So that's why the object has changed its speed, or you can say velocity. Am I clear?
Yes, sir.
Yes, sir.
Okay. So force is directly proportional to the mass into V minus U by T. That is nothing but acceleration. So, but V minus U by T represents the change in velocity with time, which is nothing but acceleration. So that's why I have substituted by this thing with the thing A. Okay. Clear, everyone?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Chalo. Just okay. And okay, so basically so this is a directly proportional sign. So whenever we are writing an equation or expression, we have to remove this directly proportional. So when we remove this directly proportional sign, so there is a constant comes into the scenario that is called K, right? So according to the scientists and all the calculations they have made so far, so the value of K is coming out to be 1. Okay.
Yes, sir.
Okay. So that is, so I am going to substitute the value of K as 1. So the thing left is F is equals to MA. Am I clear to all of you? Please do let me know.
Yes, sir.
Yes,
Is
sir.
there anyone who is having doubt till now?
No, sir.
No, sir.
Sure, that's it. Okay. So basically,
No, sir.
Newton's second law of motion gives us the relation between the force and the acceleration. How they are dependent to each other. So as you can see this thing, everyone. So the body mass is not going to change at all. So it means that if you are moving, is it possible that your body mass will change if you are walking?
No, sir.
Is that possible?
No, sir. It will be the
No, no.
same.
So it would be same. So that means that force is directly proportional to the acceleration. It means that if you increase the force, acceleration will also increase, right, everyone? Okay. So force gives the relationship between the second law of motion gives the relationship between the force and acceleration. So everyone, please see this thing. So I've basically modified this equation, just nothing but I have divided the force by time. So what I've got is A is equals to F by M. So now we are going to interpret this thing. How we are going to interpret it? So as you can see this thing, if you increase basically, acceleration is directly proportional to the force. It means that if you increase the force, acceleration will automatically increase, yes or no, because they are directly proportional. Am I clear to you or not, everyone?
Yes, sir. Clear.
But
Yes, sir.
mass is in denominator. It means that if you increase the mass, this fraction will decrease and ultimately the effect will be on the acceleration. Am I clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, that's great, Tejas. That's great. Very good.
Thank you,
Okay.
sir.
Yeah. So A is equals to F by M. So now what we can see is that if you increase the mass, the overall fraction will decrease because higher the denominator, lower will be the fraction. Am I right? So
Yes, sir.
that will leads to the lower, basically the lower magnitude of the you can say acceleration. So that's how the acceleration is inversely proportional to the mass. It means that heavy body objects, if you apply the same force to the low mass and a high mass, so low mass will gain higher acceleration and high mass will gain lower acceleration due to the
Lower.
mass relationship between acceleration.
Yes, sir.
Safia, Sara, Farhan, Tejas, Astitva and
Sir,
Farhan.
can
Clear,
you,
bacho?
sir,
Yes,
can
sir.
you,
Yes, sure.
explain again this
Acha, I'm
this
explaining.
slide?
Acha, check. Ha, Sara, you can. So, okay, I'm saying that A is equals to F by M. So it means that suppose two cars are there, M, ये इसमें 2 kgs है, ठीक है, and this is M is equals to 10 kg. So mass, so A is equals to same force applied, mass is F by 2 and mass is F by 10. Which one acceleration is higher, F by 2 or F by 10?
F by 2.
F by 2? Everyone say yes or no, kuch to bolo.
Yes, sir.
Which
Yes,
one?
F
sir.
by 2.
Which one is higher? They just said F by 2. What about rest of you? Sarah,
Sir,
Farhan,
F by 2.
Safia.
F by 2, sir.
F by 2. Sarah, Safia and Sarah? Safia and Sarah, which one is higher?
F by 2.
F by 2. Safia, your video got stuck. Please check. Please do let me know the answer. Safia, am I audible to you?
Yes, sir.
I'm asking which one is higher? F by 2 or F by 10?
2.
Yes, F by 2. It means that Safia, F by 2, because you can see this thing, the denominator is smaller, so ultimately the acceleration will increase. So that's why the acceleration is inversely proportional to the mass of that body. Clear, everyone? Just now it's clear?
Yes, sir. Clear, sir. Now, sir.
Chalo,
Thank you,
that's
sir.
Yes, sir, it's clear.
welcome. Chalo, that's great, everyone. So now let's understand some properties based on the force. That is, the force is a vector quantity. So force is a vector quantity. It has both magnitude as well as the direction, right? So it is
Yes,
a
sir.
thing that has both magnitude and the direction. Next is SI unit of force is Newton. So that Newton quantity, that Newton SI unit is given in the honor of the Sir Isaac Newton, because the force is invented, or you can say the discovered by the Sir Isaac Newton. Like, okay. Read out so far 21?
No, sir.
Sure, that's great.
No, sir.
Now let's understand what if the question comes into the exam, how you will define 1 Newton of force. So 1 Newton is that force which, when acting on a body of mass 1 kg, will produce an acceleration of 1 meter per second square in it. It means that acceleration produced would be 1 meter per second square if the force applied is 1 Newton and the mass is 1 kg. Okay, so all the things are 1. So ultimately the acceleration is coming out to be 1. Clear, everyone? So any doubt so far 21? Sarah,
No,
Stepha,
sir.
Tejas,
No,
Farhan, and
sir.
Safia. Sure, that's great. Now let's understand the applications of the Newton's second law of motion. Right. So there are some basic conceptual second law of motion questions. So catching a cricket ball. So basically, why do we basically take our hands in the backward direction when we are catching a ball, or you can say any object that is traveling with a very high speed? The thing is that we have to increase the time to basically reduce that change in momentum. So the force applied would be less. So they go m v minus u by t. So if you increase the time, ultimately the force will decrease. Yes or no, everyone?
Yes, sir.
Safia, Stitva, Sarah, Farhan, Tejas.
Yes, sir.
If you are basically
Yes,
going to
sir.
increase the denominator, your force will decrease. So
Yes, sir.
that's why we take our hand in the backward direction to increase the time for the change in momentum. That will lead to the lower force exerted on the hand. So it will hurt less, or maybe not. But if you do not do this thing, your hand will get hurt if you basically catch a very high speed moving object, and if you do not if you take less amount of time to stop that body, right? So that's why it's better to take in the backward hand in the backward direction to increase the time of change of momentum, and that will lead to the less force hurting on the hands. Okay?
Yes, sir.
So this is the statement given to all of you. A cricket player moves his hand backwards on catching a fast cricket ball to prevent injury to the hands. A fast moving ball has a large momentum. Okay? In stopping this ball, its momentum has to be reduced to 0. Right? We have to reduce the momentum to 0 because the final velocity would be 0. So final momentum would be 0. So what we do is that when a cricket ball moves a cricket player, moves back his hand on a fast cricket ball, then the time taken to reduce the momentum would be increased, will get increased. So ultimately the force is decreased, everyone. Clear?
Yes, sir.
Yes, sir.
Okay, so if the question comes as that, what thing will, if you basically, if you take your hands in the backward direction while catching a ball, what will decrease or what will affect? So some of the examples would be like it will decrease the rate of change of momentum. In some cases, the option could be it will decrease the force exerted on the hands. Clear, Safia,
Yes,
Tejas,
sir.
Sitva, and
Yes, sir.
Sara,
So
Farhan?
both of them
Yes,
are
sir.
correct.
Yeah, both of them are right. Yeah. So
Yes.
so in sometimes, like I'm just saying the statement manipulation. How could it be formed? Okay. What happens, Safia? You are not interacting that much. Is it everything? Is everything clear?
Sir, I'm having network problem.
अच्छा ठीक है कोई बात नहीं. You can switch off the video if you have network problem because I know that the main thing because my voice would be lagging if you're having network issues. You can switch off the camera. What happened, Asitfa and Farhan? Why did you switch off the camera? I just said to Safia.
Sir, my camera since the starting of the class itself, like it's lagging. Then
अच्छा
in between
lagging.
your
चलो
voice lags for me. So
ठीक
I'm
ठीक
keeping
ठीक.
it.
Okay, no issues. Yes, Farhan. Yeah, that's good. Next is the use of seat belts in the car. Now you can understand. Now you will understand why do we basically put seat belt in the car. But the thing is that seat belt will increase the time to reduce, will increase the time for the change in momentum. So that will ultimately leads to the less injuries because if you basically collide with the dashboard suddenly, if a body of a human body collides with the dashboard suddenly without any change of basically without in a very less amount of time, so that the head will get more severe injuries. So that's why seat belt is there, so basically to prevent you from basically colliding the dashboards, or maybe if you basically collide with that, the time would be much more than without seat belt. So that will basically decrease your chances of getting severe injuries. Clear?
Yes, sir.
That's great. So all the cars are provided with the seat belts for passengers to prevent the injuries in case an accident. In a car accident, fast-running car stops suddenly. Due to this, car's large momentum is reduced to zero in a very short amount of time. So just to increase the amount, just to increase the change of momentum of time, we basically place seat belts. The slightly stretchable seat belts worn by the passenger of the car increase the time taken by the passengers to fall forward and less stopping force acts on them, right? So that's why passengers may get injured, and if in case they get injured, the injuries will not be that much severe. Okay?
Yes, sir.
Is there anyone who is having doubt? Please do let me.
No, sir.
No, sir.
Sure, that's great. So these are the basic question, like just what you need to calculate the force, acceleration, and mass is given. You just have to multiply them, right? So will
Yes,
be
sir.
doing some question based on the second law of motion as well. Sorry, like basically equations of motion and all things. So what is the acceleration produced by the force of 12 Newton and exerted by a force of mass of 3 kgs? So in that you have to divide the force by mass, you will get the acceleration. But you just have to play with this, you can say the formula, right? So just a second, I'm sharing my screen. Again, just a moment. Let me raise this thing. Because we have done the very basic question, all the basics question in the class itself. I just wanted to check whether you are able to solve this one or not. Will you say, please do this question? This one, graph one. I just wanted to see whether you have revised or not. This is the second class or third class for the motion. Sorry, force.
Sir, I think second class.
Second class, yeah, because in the last class we have completed till the this is the second class.
Sir, second only.
Second. ठीक है bro. Thank you. Just second everyone. Okay, let me check who got the answers. Okay, stages, we'll discuss it. Let's solve this one first. We'll discuss it. No need to worry. Any answer by anyone? Okay, no. Okay, sir.
Sir, first part answer is 50.
Just let me know in the chat.
Okay, sir.
I always want the answer in the chat, as you know this thing. Okay. Okay, everyone. So please look at the screen. Let's solve it together because we have very limited amount of time. Okay. 1000 kg of mass. Okay. The thing is that the speed time graph is given to you, right? And as the first is basically just okay. I got okay, Tejas. Okay, that's great. Okay. So as you can see, this thing, everyone, the graph is basically first increasing. Then it has become parallel to the time axis. It means that the in this portion, what kind of motion it is basically traveling through, with what type of motion it is performing when the speed is parallel to the time axis. Please do let me know, everyone. Tejas, Sarah, Farhan, Astitfa, and Safia. What is the type of motion between B and C?
Sir, rest.
So rest.
Oh, okay. Tejas and Farhan. Sorry, Safia, Sarah. Tejas and Sarah.
Sir, that rest.
अच्छा ठीक है. Sarah.
Yes, sir.
I'm asking what is the type of motion between B and C point?
I don't know.
Don't know. Means that you haven't revised, yeah, Sarah, yet. Did you revise? Be
Yeah, I
honest
did.
with me.
Yeah, I
Motion
did.
chapter. Did you revise the motion chapter? Because
Yeah.
tomorrow is your exam, so it means that you will be revising both the chapter. I'm not asking specifically for force. I'm asking for the motion as well.
Yeah.
Check. So everybody said wrong. How is it possible that the speed is like the object is in rest? Is it distance? It is a speed, so it is going with respect to time. There is no change. It means that it is performing uniform speed motion without any acceleration. How is it possible, huh? We have done this thing numerous time in the class itself and explained it in the multiple questions, but still you are making the same mistake, everyone. It means that you haven't revised the graphs as well till now. That is not acceptable at all, Bacho. If you are not revising, how will you perform in the exam? Because physics is not a rectification thing or something like that. You have to understand and you have to revise. Unless and until you are not going to score in physics. if you're not gonna revise? How is it possible? Is this like so? But still, you did give basically you did give the wrong answer, Tejas. It's not the wrist motion. Just a second, everyone. Yes, everyone. So please tell me, did you get this point or not? That speed, when the object, when the slope is parallel to the time axis, we have discussed thing a lot of times. So the graph would be in uniform motion. If this is distance, then you can say this thing that the graph, the basically object is in rest because the distance is not changing with respect to time. But in this, speed is not changing, but still it has the speed of 15 meter per second with respect to time. So it is continuously moving with that speed, right, everyone?
Yes, sir.
Yes, sir.
And this is the retarded motion because the object is decreasing the velocity continuously. Now let's understand the first question. What is the distance traveled by the force? Oh, sorry, by the car in the first 2 seconds. So till 2 seconds, object is accelerating because the graph is in the upwards direction or is in the increasing manner. So let's find out the things in the first. So it would be distance traveled by the first 2 seconds. So in this, from A point, everyone can see this thing that this is origin 0. So it is starting from origin. So initial velocity would be 0. Okay. Final velocity in this case, what will be the final velocity, everyone? At point after at 2 seconds, the final velocity is 15 meter per second. Okay. Time would be 2 seconds as given to you. So we need to find the basically the distance covered in the first 2 seconds. So what and the okay, so in this we can calculate first, we need to calculate the acceleration because without acceleration, we cannot find the distance because this is an accelerated motion, right? So we need to find the acceleration first. Am I right, everyone? Yes or no?
Yes, sir.
So it would be V is equals to U plus 80. So V is basically 15, 0 plus T is 2 or A is A. We need to find the acceleration first. So A would be 15 by 2 meter per second square. Is it clear to all of you? Now we have got the acceleration. We can easily find the
Yes, sir.
distance traveled. Either we can use the third equation or the second equation because I have both acceleration, distance as well as the time. Okay, achha, distance we need to find. Na? So we can find like we can use the third equation as well as the second equation, right? Because I have
Yes.
initial velocity, final velocity, time, and the acceleration. So I'm going to use the second equation ut plus half at square because okay. So it would be so s is equals to ut is 0 into 2 plus of half. Acceleration is 15 by 2 into 2 into 2. So as you can see, this is getting cancelled, right? So ultimately, the value of S is coming out to be 15 meter, right?
Yes, sir.
Got it, everyone? Now
Yes,
the
sir.
question
Yes,
is saying that this is, so the first 2 seconds, the object will cover the 15 meter distance, right? So now the question is saying that what is the braking force applied by the applied at the end of 5 seconds to bring down the car in basically in rest. So if we need to calculate the force, we need to first find the acceleration produced in the last 5 seconds, basically at the end of 5 seconds, right? because force is basically nothing but mass into acceleration. We have mass, but we don't have acceleration for the last second, 5 to 6 seconds. We are not okay, because this acceleration is not valid in this case, right? We are talking about the CD case. Second point, that is, so in this point, so now please tell me everyone, at point C, the initial velocity would be 15, because at this point we are considering this interval. So the initial velocity would be 15, everyone, and the final
Yes, sir.
velocity would be 0.
Yes, sir.
So one more thing I've seen so many times, that nobody use the negative sign in the retardation acceleration. If you're not going to do that, your marks will get deducted. 0. Time is basically 1 second, right? Now we need to find the acceleration, so that would be uv plus v is equals to u plus. So v is 0, 15 plus 1 into t. So not 1 into t, it's 1 into a. So a would be equals to minus 15 meter per second square. Yes or no, everyone?
Yes, sir.
Because 1 into a is nothing but 1. Sorry, a. So now we need to find the basically force, that is ma. So that is 1000 kgs into negative of Newton. That is coming out to be minus 15,000 Newton. So this force is okay. They just break. So this negative sign is showing the retarding motion. Force is retarding. Okay? Retarding. This is negative sign is showing the retarding nature. It means that the force and acceleration both are in the opposite direction of motion. Right? Clear?
Yes, sir.
Yes, sir.
Okay, everyone. So now we have like Sarah and Tejas have doubts. So now let's clear let's take those doubts first. Then we'll continue in the next like next class. Okay? We'll continue the remaining portion in the next class. Sarah, please tell me the doubts. Farhan, Tejas, you said in the question number chapter 8, question 15. ठीक है. Just a second, Tejas. Let me open it.
Yes, sir.
Fourth chapter, na? Tejas?
Yes, sir. Force and laws of motion.
Just a second, just kidding. ठीक है, Tejas, let's solve this question. I think so we have done this question in the class. चलो ठीक है, कोई बात नहीं. Let's discuss it. This is the question based on the momentum. ठीक है. This is the question number 15 of the NCERT exercise. So how many of you have solved the NCERT exercise yet? Because Tejas is asking right now, so it means that he is solving. But what about rest of you, everyone?
Sir, which one? I couldn't hear properly.
I'm saying that the the exercise of basically the NCRT exercise.
Oh, so the textbook one.
No. NCRT exercise, Tejas, Astitva.
Oh, exemplar.
NCRT book. You have
Oh,
NCRT book. In the
yeah.
after the end of the chapter, there is a basically exercise, no? Questions
Oh,
exercise.
yes, I got it. Yes, sir. Even I'm doing.
That's it. Have you done that, Astitva?
Yes, sir, but I didn't do this question yet. Like I'm in the first chapter.
That's it.
Like,
Bacho, these are the things you have to understand. Questions comes from NCRT basically. We do the question based on NCRT. We do the variety of question. Our first priority is NCRT, but we do the question apart from NCRT as well, so that you can diversify your question practice. That is the main motive of mine. So if you do not do the NCRT exercise, so you are going to face a very big problem in the exams because the question comes from that. They will get changed the value or something like that, but the core concept will be there. So first, at least the NCRT exercise practice. Okay? Question is saying that object of mass is 100 kg, everyone. Just a second. Yeah, so mass is 100 kg, is accelerated uniformly. Take it, Tejas, we'll discuss it. Accelerated uniformly from a velocity of 5 meter per second to 8 meter per second. It means that the object has some velocity, that is u. So that would be initial velocity, yes or no, everyone?
Yes, sir.
yes, sir.
And v is equals to, so after basically acceleration, the velocity has increased to 8 meter per second, right? Time taken to increase this velocity is 6 seconds. We need to find the final momentum and initial momentum. So we need to find P1, that is initial momentum, and P2, that is final momentum, right? Also find the magnitude of the force exerted. We need to find the force as well. Now let's understand the thing first. So as you know this thing, if we need to find the initial momentum and final momentum, so this is the initial velocity. So the multiplication of mass and this velocity would be initial velocity, initial momentum, and the multiplication of this mass with the final velocity would be the final momentum. Yes or no, everyone?
Yes,
Yes,
sir.
sir.
Hundred into 5 is equals to 500 kg meter per second. Okay. Final momentum would be 100 into 8. So that is coming out to be 800 kg meter per second. Am I clear to all of you?
Yes,
Now
Yes,
the
sir.
sir.
question is saying that this is what question is asking. Now the question is saying that the force exerted by the object. So the thing is that force can be calculated using, there you go. Now we have two options. Either you calculate the acceleration using the first equation of motion because you have all the three things, you just need to find the acceleration. Or the thing is that force can be written as the rate of change of momentum. M into V minus U by T. Yes or no, everyone? I can write this thing.
Yes, sir.
So instead of that, let's write MV minus MU because we have the value of MV and MU specifically. So MV minus MU divided by T. Okay? That is MV is 800 minus 500 divided by 6. This is in Newton. Okay? So this is coming out to be 300 by 6 Newton. So this is coming out to be 50 Newton of force is exerted by the body. Clear, everyone?
Okay, sir.
Is
Yes,
this
sir.
clear, हुआ बच्चे?
Yes, sir. Clear.
Chalo, that's great. In the Lakshmi Singh, you have
No,
doubt
no, sir.
in
It
the,
got clear, sir.
it got clear in the Lakshmi Singh one?
Yes, sir.
Chalo, that's great. I think so similar question होगा. ठीक है, chalo, that's great. Sarah, what was your question, बच्चे? Please let me know.
Sir, I have sent the another question.
Acha, you have sent the another question. Ball of, is it from the Lakshmi Singh Majid Court, Tejas?
Yes, sir.
Okay, please, could you please tell me the number, because I have to take the step so that I can paste it on the screen. Because I can, like, if I write it, that will take a lot of
The
time.
question number 60 from question
number
based of
60.
horse.
It's a question number 16.
60, sir.
Just a
60.
second. 60.
Yes. Horse
Acha,
question,
ठीक है,
sir.
ठीक. Tejas, this question is based on the, you can say, conservation of momentum.
Okay, sir.
Yeah, so this question is based on the conservation of momentum. So that's why once we will do the chapter, we will solve this one. Okay. Once we'll solve this, basically, once I will take the conservation of momentum class, we will solve it. Okay.
Okay, sir.
Because if I explain you right now, you will not get understand properly. Okay, you will get the method, but the thing is that the concept clarity should be there. Yes, sir. Okay,
Yes,
we
sir.
just will discuss it. No need to worry.
Okay,
I'll
sir.
keep this thing in my mind. Okay. Well. Do you have anyone? Is there anyone who is having doubt?
No, sir.
Okay, Safia, Farhan,
No, sir.
Check. Sarah, I'm asking something, bache. Please do let me know the questions.
So the question is differentiate between velocity and acceleration.
Differentiate between velocity and acceleration. Okay, I'm basically telling you right now like this. So you can make these statements, but okay, I'm telling you the core concept, or you can say. So is this a part of the, you can say, any assignment book or something like that, Sarah?
It's in my model question paper for my
ठीक है.
exam.
So देखो, difference between velocity. So velocity is basically rate of change of position. It means that if you change the position with respect to time, so whatever is the rate, that is called as the velocity. If we talk about the acceleration, rate of change of velocity is called acceleration, right, everyone? Because I've
Yes,
just
sir.
told you in the second law of motion. Okay.
Yes, sir.
Second is, if you take the difference, so I don't like a vector quantity will not be different because both are vector quantities.
Yes.
And
Sir, SI unit.
only the SI unit, only two things are there that could differentiate velocity and acceleration. Let's just say, because all the properties are same because both are vector quantities. The only thing that differs from the definition. So SI unit is it a 2 markers, Sarah?
Yeah, only 2 marks.
Only 2 marks. So check it, satisfied. SI unit is meter per second. In this, SI unit is meter per second square. So 2 marks,
Yes, sir.
2 bullet points are enough for the 2 markers. Okay. SI unit is meter per second square, because apart from these two, I don't think so there is any difference between these two, because
Yes,
velocity
sir.
and acceleration both are vector quantities, so they will be having both negative and positive values. Velocity and acceleration depends on both magnitude as well as the direction, because vector quantities are. So these are the two things that is the basic difference from the velocity and acceleration. Yes, Sarah, please tell me the other question.
Yes, sir. 1 minute.
Is this clear to all of you? Farhan, Safia, Stefan,
Yes, sir.
Tejas?
Yes, sir.
Chalo, ठीक है. Okay,
Yes,
this could
sir.
be a question. देखो, this is the model question paper, so this could be a question in your exams as well, right? So that's how the doubts classes will enhance your performance and your knowledge. So I'm requesting to all of you, please take some of your doubts as well in the class so that we can discuss them. Revision is a part, but the doubts are almost or basically are also necessary for that.
Yes, sir.
Chalo, that's great.
It's a MCQ question,
Hmm.
which would be, what would be the displacement of a particle moving in a circular path of a radius r after displacement of half a circle? Option A is 2 pi r.
Sarah 2R. We have done this
Yes,
question in the
sir.
class. देखो. If I see you the question, this is the same question we have done in the class, Sarah. देखो. A particle moving in a circular path of radius r, the displacement after half circle would be 2r. If you, this is also a question in the basically you can say in the like revision classes we have done this question a lot, and the class
Yes.
itself we have done this question. Right? Got it, Sarah? This would be 2r. This is the explanation. Let me tell you. if we talk about distance first, let me tell you in the proper detail. If we talk about distance, Sarah, if you are starting from this point, if you are taking the complete one round, it means that you are basically covering one circumference of one time the circumference of the circle. That is 2 pi r, right? So after completing one circle, your displacement would be 0 because you are coming back to the original position. Displacement would be 0 for full circle. We are not talking about half circle. This is full circle. Now let's talk about for the half circle, Sarah. The distance in half circle would be, you are covering only half path, half circumference, so 2 pi r divided by 2 would be pi r, right? And now let's talk about the displacement. So just think about the displacement definition that is given here. The shortest path in a straight line between final and initial point, first position and second position. The straight path is basically between the basically is along the diameter of the circle. So that is coming out to be 2r. So 3.14 I have placed the value of pi. So as you can see this thing, 3.14 r and 2r. Which one is bigger, Sarah? You are muted, Sarah. You are muted.
3.14 hours.
3.14. So that's why we talk about this always shortest path. So among these two, the 2r is the shortest part. So that we will consider as a displacement. Clear?
Yes, sir. Yes, sir.
So this is the thing we have done this thing, Sarah. Okay? Clear everyone? Now, do you have any doubts, Sarah? Please do let me know the another question.
No, sir, I don't have any doubts.
Chalo, ठीक है. So these are only these two things are there that can differentiate velocity and acceleration. Otherwise, all the properties are same because both are vector quantities. Both can be negative and positive. Both depends on the acceleration as well as the both depend on the direction as well as the magnitude. Okay? So
Yes,
that's
sir.
why only two properties are there that could differentiate between velocity and acceleration.
Sir, what is
ठीक है, sir?
tangent of a circle?
Tangent circle hota hai Tejas, that this is a circle. The line which cuts or which line which basically intersects or touches the circle at a single point only. Only a
Okay,
single
sir.
point. You will study this
Okay.
thing in the 10th standard stages. Right now, you are going to study the chord. 2 point, the intersection of a line, basically the intersection of circle by a line at 2 points. So
Yes.
that will be considered as the basically your chord. But if you take that chord, let me show you with the example right here. Tangent is a special case of chord. Okay, so this is the line. Okay, this is the line, everyone. So this line is cutting the circle at 2 points, intersecting the circle at 2 points, right? So that
Yes,
will
sir.
be called as chord. But if I take this line right here, somehow, if I right now, the only like this is a little bit more area covered in that. But if we just assume that thing, so you can see this thing that the circle is only touching at a single point. So that is called the tangent. So tangent is the special case of chord. And on every point, only one tangent can be drawn. So circle is the point of many, you can say infinite point. Is basically you can say is
Yes,
made
sir.
up of infinite points. So every point has only one tangent. Right, everyone?
Yes,
So
sir.
Yes, sir.
clear? So that is it.
Yes, sir. Clear, sir. Thank you.
Okay? So this is the special point. So this you will understand in the 10th standard. Okay? So the right now just understand the chord. Okay? So clear, everyone?
Yes, sir.
Yes, sir.
Chalo, that's great. Okay, that's great. So Sarah, is this clear to you, bache?
Yes, sir. I have one more question.
Please ask. Just a second. Let me have a sip of water. Yes, Sarah. Please do let me know.
What is uniform circular motion?
This is the uniform circular motion definition. Uniform circular motion is the motion in which the object is basically moving in a circular path without changing the speed. Okay, if the object is not changing the speed and moving in a circular motion, that is called uniform circular motion. In that, Sarah, this speed is not changing, but the direction is changing continuously. So that's why this is called accelerated motion, because velocity depends on two things, Sarah. Magnitude, direction, right? If you are not changing this magnitude, or you can say speed, only thing that is changing is direction. So if any of the two things changes, the velocity will change. It means that it is accelerated motion. So that's why this is called accelerated motion, because direction is changing continuously at each and every point. Clear? So that's why
Yes,
you can
sir.
see this thing. When a body moves along a circular path, then its direction changes continuously. Since the velocity change, I've told you that since the velocity changes continuously, the motion along a circular path is said to be accelerated, because velocity depends on direction. So direction changes, velocity changes. It means that acceleration is there in the motion. Okay? So now, when a
Yes,
body
sir.
moves in a circular path with uniform speed, motion is called uniform circular motion. Right, Sarah?
Yes, sir.
And the force required to produce the circular motion is called centripetal force. Centripetal force is required to produce the circular motion. Am I clear to you, Sarah and everyone?
Yes,
Yes,
sir.
sir.
Tejas, Farhan, and Safia.
Yes, sir. You're clear, sir.
Okay. These are the things that we have done in the class, but the thing is that you have to revise to understand it properly. Without that, you are not going to understand a single topic, because after this now we will be starting the work and power energy. So basically work power energy involves all the things that we have done so far in the motion as well as the force chapter. Because the definition of work is, I'm going to tell you, definition of work is basically force into displacement. The force is there, displacement is there. Both the topics are from, this is from force and laws of motion, this is from motion chapter.
Yes,
Right,
sir.
everyone?
Yes, sir.
That is the
So it's force into displacement, right?
force into displacement.
Yes, sir.
So if you do not understand these things properly, so you will get like trouble in the coming chapter, in the basically work power energy. Both gravitation and sound are independent chapter, but the basically work power energy, force and laws of motion, and motion are like brothers. They are related to each other. They share the DNA. Okay? Some biology
Okay, sir.
terms I've used. Clear, everyone? Sarah, Farhan,
Yeah.
Astitva, and
Yes,
Safi, and
sir.
Tejas.
Yes,
Yes,
sir.
sir.
So
Yes,
please and
sir.
please do the revision. Okay?
Okay, sir.
So
I'll
that's all for this class for today, everyone. Okay? So in the next class, we are going to complete the chapter. So what I will do is that in the revision class, I'll basically let you know that whether I would be able to cover the conservation of momentum in the revision class or not. I will let you know in the next class. So if yes, so we'll do that in the extra class. It's a revision class itself. If not, we will do some in other portion. Right, stages, everyone?
Okay,
So those
sir.
who want to join can join. But once I will tell you, right?
Okay, sir.
Chalo, that's it. So that's all for this class, everyone. Thanks so much for joining and giving
Thank
me your
you,
time.
sir.